We've talked a lot about slope this semester, and so I wanted to take a day to, or half a day, to review all the different concepts of slope. We're going to build on our idea of slope tomorrow, but slope definitely comes up in a lot of different ways on your final exam, and so this is also sort of the start of our review. So we know that slope is represented by the letter m. This is really important, right? Slope is always represented by letter m, and y equals mx plus b. And so just always being aware that letter M represents slope. And so I'm going to show you, we've talked about two different ways to figure out slope. And there's actually a third way that I think some of you have learned before, but I want to just share with everybody. And it's sort of the same. They're actually all the same, which is what I'm going to discuss right now. But it's very similar to the change in y over change in x, but just a different way of doing it. And so from here on out, whichever one you're more comfortable with is totally fine. You can just use whichever. So basically slope equals rise over run, slope equals change in y over change in x, and slope also equals, this is what's called the slope formula, and you read it like this, y2 minus y1, x2 minus x1. So we'll get to this in a second, and it's actually very much the same as this, but I want to sort of show you how all of these are actually the same thing, because slope, if I'm talking about the slope of a particular line, it's not like there's different slopes. There's one slope, and there's just different ways of figuring it out. So let's say we're talking about the slope of this line, the one that connects the point 1, 3, and, oops, sorry, that's not 1, 3. I'm mixing myself up. 1, 3, and 3, 7. Right, so let's say we have this line, 1, 3, and 3, 7. And I'm going to draw a line here. I'm just going to use the edge of my do now because I have nothing to draw it with. Okay, so here's the line. And I want the slope of this line. Okay, now there's actually three different ways to find the slope. And so let's start with this idea of rise over run. On the graph, I'm going to use green for the rise and blue for the run. And on a graph, basically, I can just count. I can say, well, what's the run? What's the distance from this point to this point from left to right? And so I say, well, I'd have to go, in order to get from here to here, I'd have to go 2 spaces. And then the rise, what's the rise? Well, how many spaces would I have to go to get in the up and down motion to that second point? And it would be 4 spaces, right? So in this case, the run is 2 and the rise is 4. And so if I were to want the slope, I would say, okay, well, the rise is 4 and the run is 2. And so I can simplify this. This is 4 divided by 2. The slope is 2. Okay. Now, this next method, I want to show you how it's very much the same. It's called change in y over change in x, right? This symbol is called delta. That's what the symbol is called. You'll see it in science as well as math. And it just means change. So this means how much does the y value change and how much does the x value change. And the strategy that we've been using to figure this out, and this is just a strategy that I made up, it's not necessarily a strategy you have to use, but I've just been listing, right, here's the 2 points I gave you. I gave you 1, 3, and this point is 3, 7. You can just list the 2 points. Well, here's the x value and the y value, and the x value and the y value. And we've been saying, okay, well, what's the change? To get from here to here, how much does the x value change? Well, to get from 1 to 3, I'd have to add 2. And to get from 3 to 7, I'd have to add 4. And what you might notice is that when I go to write the change in y over the change in x, what do I end up with is the same exact fraction as I ended up with rise over run. Well, here's why. Because this, to get from here to here, is 2 spaces on the graph. But what it also is me moving from an x value of 1 to an x value of 3, right? Here's the x value of 1, and here's the x value of 3, and it's 2 spaces. It's also plus 2, right? That's not a coincidence. That's because these spaces on the graph represent numbers. So in order to get from 1 to 3 is 2 spaces, and I would add 2. And then, so that's the x value changing by 2 units. So that's the change in x. And then the y value, well, the y value starts at 3, right? The y value starts here at 3, and then in order to get up to that second point, the y value has to go up all the way to 7. Well, what do I have to do to get from 3 to 7? Well, here I have to go up 4, that's my rise, and to get from 3 to 7 sort of in numbers, I have to add 4. But that's the same thing, me going up 4 and me adding 4, those are the same. This is just different ways of representing it. So again, 4 divided by 2 is 2. So still, the slope, if I use those same 2 points, is still the same. It's still 2. Now, the slope formula. This is basically a way to do this, change in y over change in x, as a formula, as something you can sort of memorize and just plug in. And so if you find that easier, that's totally fine. But basically, here's how it works. You take a point, you take 2 points, right? And you label them like this. And it's always the same labels. This is x1, y1, right? This is like point number 1, x value and y value. And this is point number 2, x value and y value. And so we label it like this. And notice the 1 and the 2, they're not exponents, right? It's not x squared, right? It's not that. It's like this, with the 2 at the bottom. And basically what that's saying is, well, there's actually 2 x's, so I'm just going to use the letter x, but I'm going to say, well, this is the first x, and this is the second x. And then here's the slope formula, right? And it basically says this, it says the slope equals y2 minus y1, x2 minus x1. So y2, look, here's what I do. y2, I go and I say, okay, well, what's y2? y2 is 7. Minus y1, what's y1? 3. x2 is 3. Minus x1 is 1. Then I do the math. 7 minus 3 is 4. 3 minus 1 is 2. And again, I get the same answer. Okay, and notice, I get that same fraction, 4 over 2. Again, it's not a coincidence, right? For me to say, well, what do I have to do to get from 3 to 7? That's the same as asking, well, what's the difference of 7 and 3? What's the difference? What happens if I subtract these? It's literally the same, right? This, talking about what's the change from 3 to 7, is the same as doing 7 minus 3. So all 3 of these things are actually the same thing. They're just different strategies. And all 3 are things that you can use to find slope. These 2 are very, very much the same, right? You're given 2 points, and there's basically just different strategies as to how you could find that change in y over change in x. Now, the graph, sometimes it's inconvenient to use a graph. Let's say you don't have a graph, or let's say your numbers are really big. So sometimes you'll find, using the graph doesn't really work. So I'm going to go ahead and do the first row of this table, and then let you pause and try the next 2 rows. And I'm going to give you an opportunity to check your answers in these bottom 2 rows, but I also do want to make sure that you try them. If you feel like you're ready to try this first row now, you can pause and try the first row before I do it. Let's see. Find the slope of the line that connects 1, 2, and 4, 6. 1, 2, and 1, 2, 3, 4. Okay, so I'm going to draw my line. I'm just going to keep using my do now. All right, my rise is this distance here. My run is this distance here. So let's see, my run is 1, 2, 3. My rise is 1, 2, 3, 4. So my rise over run, my rise is 4, and my run is 3. Okay, so this is it. I can't simplify 4 over 3. That's my slope, right? 4, like here, 4 divided by 2 was 2, but 4 divided by 3, I mean, it's a number. It's 1.3 repeating, but I don't need to do that. Just 4 over 3 is fine. If it doesn't divide, it doesn't divide, and you can keep it as a fraction. Okay, change in y over change in x. So again, here are my points, 1, 2, and 4, 8. So here's 1, 2, 4, 8. And what change do I have to do to get from 1 to 4? Well, I have to add 3 to get from 2 to 8. Uh-oh, sorry. This is supposed to say 4, 6. Doing all the same. Sorry, guys. 4, 6. Okay. And so get from 2 to 6 is plus 4. So then change in y over change in x equals 4 over 3. Can't simplify that. Same answer. Okay. And slope formula. Here are my 2 points. This is x1, y1, right? That's my first point, x1, y1. And here's my second point, x2, y2. Okay, so then when I go to fill in the formula, and really be careful to write neatly, because if you write messy, the y's and the x's can look kind of the same. Y2 is 6 minus y1 is 2. x2 is 4 minus x1 is 1. 6 minus 2 is 4. 4 minus 1 is 3. And I get that same answer. Okay? 3 different ways to do the same thing.